All right, here's number 17. So we have negative 8z is less than or equal to 4. So just like before, if I want to get z by itself, I would divide both sides by negative 8. And so I get z. But remember, one thing here is when we divide by a negative or multiply by a negative, we have to flip the inequality around, right? So that less than or equal to is going to become a greater than or equal to. And then negative 4 divided by negative 8 is negative 1/2, right? So we can divide 4 divided by 4 is 1. Yellow is kind of hard to see, huh? 4 divided by 4 is 1, and 8 divided by 4 is 2. Cool, and then that negative is still there. All right, so z is greater than or equal to negative 1/2. So we can plot negative 1/2, which is the same as negative 0.5, right? We can put, this time we have greater than or equal to, so it's going to be brackets. Okay, so greater than or equal to, and then it's going to go to the right because it's greater than or equal to. All right, so there's our number line representation, and now we want to put an interval notation. So we're going to put negative 1/2. You can put negative 0.5 if you want to, and that's fine if you put it here as well. Okay, and so as long as it's exact and simplified, right? So this endpoint's included, so we put the brackets from negative 1/2 all the way to positive infinity, and always put parentheses around infinities. All right, there we go. Okay, so this next one, we have 3 minus 9z is less than or equal to 6. So I'm going to subtract 3 from both sides. Get negative 9z less than or equal to 3. And then we can divide both sides by negative 9. Right? Key word there being negative 9, right? So what's going to happen? That's right. The inequality flips around. So we end up with z is greater than or equal to 3 divided by negative 9 is negative 1/3. Okay. All right, so we're doing the number line. Since we don't have any values here, you could do this a couple different ways. You could put, let's put 0 in the middle here, but you could put 0 anywhere. And then if we're doing negative 1/3, let's go by thirds. Negative 1/3, negative 2/3, negative 1, right? We could do it that way. So this would be positive 1/3, positive 2/3, positive 1. And this would be 1 1/3, also known as 4/3, 5/3. Then we'd have 2, right? Which would be 6/3. This would be negative 4/3. Okay, so you don't have to label every little thing. Really the main thing I want to see is, this right here. Okay, and if you need to approximate, you can do that too. But just make sure that your answer here is exact. Okay. All right, so we'll go from negative 1/3, and z is greater than or equal to. So that means we're going to have brackets. And greater than or equal to means it's going to go to infinity. Or it's going to keep going to the right forever, right? So that's how we write an interval notation. All right. So same thing here, right? Just kind of think of it as an equal sign unless you multiply or divide by a negative. That's the only time it has a little different twist, right? Is when you have to flip the inequality around. Other than that, it's pretty much the same. So I want to get my p's on the same side here, right? So if I add 4 to both sides, that'll help me to stay positive. So I'm going to do that, add 4p to both sides. Oh, and let's just, while we're at it, if I'm moving my variables to the right, I'm going to move my numbers to the left. So I'm going to add 8 to both sides. So 5 plus 8 is 13. It's greater than negative 3p plus 4p is 1p. Okay, so we get 13 is greater than p, or we can think of it as p is less than 13, right? You can think of it either way. All right, and so I want to put, so I can, you know, if I wanted to get 13, I can start anywhere with 13, right? Remember, you don't have to label it everything. The main thing I want to see is your endpoints, right, and so forth. So, so I'm going to put, this time we have a less than without equal to, so it's going to be parentheses on 13. P is less than, so we're going to head to the left. All right, and then interval notation, we're going negative infinity all the way up to 13, parentheses around both. And another one, so this time negative 56q is greater than or equal to negative 20. So I want to get rid of that negative 5/6, so I'm going to multiply by the reciprocal, negative 6/5. The negative turns to positive. Then we got to do the same thing to this side, right? Multiply by negative 6/5. Okay, so if we multiply this by negative 6/5, remember this is 20 over 1, and so 20 and the 5 cancel or reduce to 4 over 1, right? And so then we have a negative times a negative, so those are going to turn positive. So it's really just 4 times 6, which is 24. And the q comes down, but we have to remember to flip this inequality around because we just multiplied both sides by a negative. All right, so we get q is less than or equal to 24. So we want to put 24 somewhere on our graph, and then we can go from there. All right, and so less than or equal to means brackets. I'm going to put a bracket on 25, and it's less than, so it's going to go to the left. And so we get negative infinity all the way up to 25, and the 25 is included. All right, 29. So I'm going to get t by itself. So I'm going to subtract 1 from both sides. All right, so I have 1/8 minus 1, so I'm just going to do this off to the side over here. 1/8 minus 1, I'm just going to make it 1 over 1. Then I want to multiply by 8 on top and bottom to get a common denominator. So I get 1 over 8. 1 over 8 minus 8 over 8, and that equals negative 7 over 8. All right. So now we still want to get t by itself, so we're going to multiply by the reciprocal of negative 1/4, which is negative 4, or negative 4 over 1. So those cancel out. Negatives turn to positive. So I'm going to get t. Have to flip this around because I just multiplied by a negative, so it's going to be less than or equal to. And then we see here that the 4 and the 8 reduce, right, to 1 over 2. The negatives turn to positive. So I get 7 times 1 on top, which is 7, and 2 times 1 on the bottom, which is 2. So t is greater than or equal to 7 over 2. So that's also equal to 3.5, right? So you can, oops, let's not do that. So you can also write it like this. Okay. So when you're graphing it, you can start anywhere you want. But let's say we started at 0 here, 1, 2, 3, 4, 5. You could also do half. half marks, right? Okay, so t is less than or equal to 3.5. So 3.5 is between 3 and 4, right in the middle. And so less than or equal to, so I'm going to put brackets, then I'm going to go left forever, and that's it. So when I have to write this in interval notation, it's going to be negative infinity, parenthesis on that side, all the way up to 3, and that's included